Okay, so what I'm going to look at in this lesson is this idea of quadratic equations with complex roots. So we've come across this guy before, so the quadratic equation, and we can use it to solve quadratics that are in this form here. And basically what you end up doing is you find out, for example, the roots, or for example, the values that satisfy this expression, the values for x. And generally you're going to use this guy for quadratic equations that you can't get factors for through the normal trial and error method. Now what's really interesting in relation to this is that if you take, for example, sometimes you might get a quadratic and where this part in here, so for example where this part, I'm just going to put it in, so where this part here, b squared minus 4ac, where this is negative, where this ends up negative, the roots will generally be a complex number. So where this, so where b minus 4ac, where this works out to be a negative number, and you're getting the square root then of a negative number, the root is going to be a complex number. So we've kind of looked at how, the whole idea, the reason why we use complex numbers is to get, things like, for example, the square root of minus 4. So this isn't a real number, it's going to be a complex number that we need in order to get this. So if you remember, when we're using this, basically all you're doing is, so your quadratic will look something like this, and you're taking the numbers, for example, the coefficients or the numbers a, b, and c, and you're just plugging them into this formula, and you're working it out. So what we can do is we can actually use quadratic equations to get this quadratic equation to get the factors of, for example, a quadratic where this here is going to end up working out to be negative. So we can have a look at an example of this. So if we take this quadratic, for example, so we have z squared plus 6z plus 10 is equal to 0. And what you're being asked to do is to solve this, so solve it and express in the form a plus or minus bi. So we can see here we're expressing it in the form of a complex number. So you have this is the real part, and then this is the imaginary part. What we do then is we can just identify each part here. So for example, remember, so this is z squared. Now there's going to be a 1 in front of that. So remember, there's always a 1. It's implied that there's a 1 there that's in front of that. So what we want to do is we want to identify each of these parts here, for example, within this quadratic. So for example, the 1 here, that's going to be a, okay, the 6 is going to be b, and the 10 is going to be c. So now what we can do is we can use this quadratic equation here to work out and to solve this guy here. And what we can do is we can just let this be equal. So instead of using x, so we're not using x, we're just using z instead. So we can write it like this. So z, so we're trying to work out what's the value or the root, what I call the roots of the quadratic equation. So what values of z satisfy this equation, that when you plug it in here, it's going to be, this will work out to be 0. So z is going to be equal to minus 6. Okay, so remember, so it's minus whatever the value is for b, and we can see here the value for b is 6, so it's minus 6 plus or minus the square root of b squared. So remember, b in our quadratic is 6, so it's going to be 6 squared, which is just 36, minus 4 times ac, so 4 times, so ac, and in this case a is 1, so it's 4 times 1, times c, which in our case with this quadratic is 10, and that's all going to be divided by 2 times the value for a. Okay, so 2 times a. So a is, in our case, it's going to be 1. Okay, so that's what we do. So we take our quadratic here and we plug in the values into the quadratic, and now what we can do is we can start to solve this. So this is going to be, if we work this out, so we have, so it's going to be 4 times 1 is 4, and then 4 times 10 is 40, and then 36 minus 40 is going to be equal to minus 4. So this will simplify down into minus 6 plus or minus the square root of minus 4. So notice the way this part here, okay, which is this, in this case it has worked out into a negative number. So that means that the roots, for example, are going to be complex numbers in this form. They'll have a real part and an imaginary part. And then that's all divided by 2 multiplied by 1, which is just 2. 2 by 1 is 2. Okay, so that's what it looks like. And now what we can do is we can start to solve this. So if we think about this part here, so we have to solve this. So if we take the square root of 4, so we'll look at this because we've looked at examples of this. So remember when we have, for example, the square root of minus 4. So how do we work out what that is? So what we have to do is we get, so remember it's going to be the square root of positive 4 multiplied by, and we can just use a dot, the square root of 1. So remember we done these, sorry, the square root of 1, minus 1 should I say. So the square root of minus 1. And then minus 1, the square root of minus 1 is equal to I. So remember we have this rule, the square root of minus 1 is just equal to I. So what we can say then is we can replace this with I, and the square root of 4 is going to be, so 2 2's are 4, so it's going to be 2 multiplied by I, which is just equal to 2I. Okay, so this part up here, this is just going to simplify down into 2I. So it'll be minus 6 plus or minus 2I divided by 2. So it looks something like that. And now what we can do is we're just doing what we done at the very start. We're just taking a complex number and we're dividing it by a real number. So we just divide each part by this real number. So if we think about it, so minus 6 divided by 2 is just going to be equal to minus 3. And 2I divided by 2 will just be equal to I. So it'll be minus 3 plus or minus I. So that's what it's going to look like there. And then what we can say then is that, so the roots, for example, the roots of this quadratic are going to be, you're going to have 2 of them. You're going to have minus 3 plus I. Okay, so that's root 1. And then you're going to have minus 3 minus I. So that's what that means there. So these are the 2 roots. So these are your answers. So that's root 1 and that's root 2. And we've used this guy here. And what do we mean by roots? Well, we mean that if we were to take this guy and substitute it into this expression and work it out, it'll equal to 0. So if we take, for example, so we just take this quadratic here. So z squared. So for example, so z is equal to that, or z is equal to that. So if we take, like, just as an example, so this is a root. So if we have a look at this and we substitute it in here, so that's going to be equal to, so let's say z squared. So when z is, so it's going to be minus 3 plus I to be squared plus 6 times z to be squared. So again, it's minus 3 plus I plus 10 will be equal to 0. And this will work out as 0. So what we can say is, so this here would be minus 3 plus I multiplied by minus 3 plus I. So what is that? So minus 3 by minus 3 gives me plus 9. Minus 3 by plus I gives me minus 3i. Plus I by minus 3 gives me minus 3i. And then plus I by plus I gives me plus I squared. And then we can bring this down. So 6 by 3, that gives me 6 multiplied by 3, minus 3, that gives me minus 6, and 6 is 12, is minus 18. And then plus 6 by plus I gives me plus 6i plus 10 will be equal to 0. So then what we can do is we can work this out. Let me just move this down a little bit here, so you can see. Okay, so let's have a look at this. So we can collect up some of our terms. So we have, so let's say, so where we have I squared, we can just replace that with minus 1. So this will become, so it'll be, so let's say we have, so, okay, so 9 plus 10, that's equal to 19, minus 18, that's going to be equal to 1. Okay, so that's just going to be equal to, that would be equal to 1, and then minus I, minus 1, that's going to be, that will cancel out. So let's have a look. Okay, so let's just collect up what we have here. So if we take the 9, the minus 18, and the plus 10, so that's going to be equal to, so that will simplify down, so that's 19 minus 18, that will just be equal to minus 1. Okay, so that's these guys here. So we can, and then we have minus 3i plus 6i. So minus 3i, that's just going to be equal to, that will be equal to minus 6i. And then we have plus 6i. So they'll just cancel out. Okay, so they'll cancel out with each other. So that's these guys here. And then we have, sorry, this will be plus 1. And then this, so this plus I squared, that will just work out to be minus 1. Okay, so plus 1 and minus 1 is 0, is equal to 0. So we can see here that the root, what the root means, that it means basically it's the value for z. So we can see that when we substitute this root into this expression, it's equal to z. Now another thing as well to notice about this is that, so you'll notice that one of the roots, for example, is minus 3 plus I, and the other root then is what's called its conjugate. So notice that the only difference between this root and this root is that then instead of having plus I, it's minus I. So that's using, so for example, that's just using where we can use the quadratic equation to get the roots of a quadratic, where this part in the quadratic is going to be negative, and the roots are going to end up being what are called complex numbers. And that's basically how we can use this to solve for the roots. And it's basically how this quadratic equation, for example, how it fits in with complex numbers. Okay, hopefully that makes sense, and thank you for listening.